Welcome back to The Explainer. Today, we are diving deep into something that's literally shifting how developers build AI applications. We're going to unpack Anthropic's brand new design patterns for agentic AI, and specifically look at how you can bring them to life using practical crew AI implementations. If you've been wondering how to make your AI less chaotic and way more reliable, you are in exactly the right place. Let's get started.
Okay, let's dive into this. So what exactly are agentic design patterns? Well, think of them as your standardized architectural blueprints. They are predictable structures, like specific workflows or autonomous agents, that give you a totally reliable framework for building complex LLM-based apps. In the Wild West of AI development, these patterns are the structural blueprints that finally bring order, standardization, and most importantly, reliability to your code.
Which brings us to a massive everyday problem for developers. How do you tame an unpredictable AI? We all know that raw LLM calls are notoriously chaotic. You ask a model to do 3 things, it forgets one, hallucinates another, and suddenly your customer support bot is inventing its own programming language. The ultimate solution to this unpredictability isn't just writing a better prompt. It's wrapping that reasoning engine in these structured, highly reliable design patterns.
To get us from high-level theory down to the actual code, here is our roadmap for the explainer. First, agents-first workflows. Second, the augmented LLM. Third, pattern 1, prompt chaining. And finally, pattern 2, routing.
Section 1. Agents versus workflows.
So, Anthropic recently identified a huge paradigm shift. Instead of lumping everything under the broad label of agentic AI, we really need to split it into 2 distinct categories. On the left, we have fully autonomous agents. Think of these as dynamic, highly capable managers. You give them a goal, and they autonomously make decisions, pick their own tools, and figure out the steps totally on the fly. On the right, we have workflows. These are like a highly structured assembly line. They're semi-autonomous and operate on a strict, predefined set of steps that you, the developer, mapped out in advance.
The Anthropic breakdown summarizes this trade-off perfectly, stating, many applications benefit from the predictability of workflows, while more open-ended tasks need the flexible decision-making capacity of autonomous agents. The crucial takeaway here is that neither approach is inherently better. It completely depends on the specific level of complexity and predictability your application actually needs.
Section 2. The augmented LLM.
Now, what's really interesting about this slide is that this augmented LLM is the foundational building block for every single pattern we're going to discuss. Think about it. An LLM on its own is essentially just a brain in a jar. It's an incredible reasoning engine for sure, but it can't interact with the real world at all. To make it useful, we have to augment it with 3 core components. First, actions or tools, kind of like handing a doctor a stethoscope and a thermometer. Second, retrieval. This is using vector databases to fetch real-time, updated data that simply wasn't in the model's training set. And third, memory, which is the system's ability to store user states, track past conversations, and actually learn over time.
But here is a really vital detail you'll notice in these architecture diagrams. The connections are usually drawn as dotted, optional lines. Why? Because all 3 of these components, actions, retrieval, and memory, are entirely optional. The AI decides dynamically when to use them. If a user simply says hello, the AI isn't going to search a massive vector database or trigger a complex tool just to say hello back. It selectively pulls in these augmentations only when the task actually demands it.
Section 3. Pattern 1, prompt chaining.
All right, let's move from theory straight into practice. The source material defines prompt chaining as a sequential workflow where the output of the first function instantly becomes the direct input for the second function, and so on. It is a straight, predictable pipeline. Step A finishes up and immediately hands its homework directly to Step B. This is incredibly powerful for breaking down massive, complex generative tasks into really manageable, highly focused chunks. And this brilliantly illustrates exactly how it works, using the practical crew AI code example from the source material. Look at this flow. Step 1. The AI generates a random Pakistani city name. Let's go with Lahore. That exact output, Lahore, is immediately passed over to Step 2. Where a separate, specialized LLM call is asked to write fun facts specifically about Lahore. Finally, those generated fun facts are handed off to Step 3, which seamlessly saves that exact text straight into a markdown file called fun_facts.md. It's clean, it's linear, and it's completely predictable.
To actually build this in Python, the instructors highlighted a fantastic visual analogy. You can think of crew A decorators as literal traffic lights for your code. You simply drop the @start decorator on your entry point. That is your green light. Then you use the @listen decorator on your subsequent functions. That @listen decorator acts just like a red light that magically turns green the exact moment the previous function completes. There's no road rage, just a smooth sequential flow without having to map out any complex edge logic like you'd have to in other frameworks like LangGraph.
So how does the actual data, like our city name, physically move through these traffic lights? Well, developers essentially have two choices. You can either return the value directly from one function right to the next, or, even better, you can use dynamic state schemas, like self.state.city_name. By attaching the data to the state object this way, you make that variable universally available everywhere in the workflow. Any node can access it exactly when it needs to.
Section 4, Pattern 2, Routing.
This is where we get to inject dynamic decision-making back into our highly structured workflows. Because let's face it, here's the fundamental issue with strict sequential chaining. How does the AI know which path to take when handling diverse inputs? If your app receives a highly technical support ticket versus a simple sales inquiry, a straight line just isn't going to work. You need a workflow to branch out and handle those totally different types of user requests differently. Which brings us directly to the Anthropic definition of routing. Routing is basically the process of classifying an input and then directing it to a specialized follow-up task. Why do we do this? To completely prevent one generalized prompt from trying to do absolutely everything, which we know is guaranteed to hurt performance. By routing, you're separating concerns. You let one specialized model handle the classification up front, and distinct, tailored functions handle the actual execution.
Let's look at the live code example from the source to see this in action. They set up some straightforward conditional routing logic. First, the system generates a basic greeting, and then it randomly picks one of 3 cities. Based on that single choice, the routing logic kicks in. If the city is Karachi, boom, the flow branches entirely to a specialized Karachi function. If it's Lahore, it routes right to a specific Lahore function. And if it's Islamabad, it heads straight down the Islamabad path.
Let's move to and see how this builds out practically in the CrewAI framework. Instead of just relying on @start and @listen, developers bring in the @router decorator. This acts as a highly intelligent junction box. It evaluates the output of the previous noder, in our case, the selected city, and runs standard if/elif statements. Based on those specific conditions, it dynamically controls the flow of execution, firing off only the exact follow-up node that's required for that specific path.
We have covered a tremendous amount of ground today, all the way from the high-level philosophy of Anthropic's agentic patterns right down to the traffic light decorators of CrewAI. By moving away from raw, chaotic LLM calls and actively embracing workflows, augmented LLMs, prompt chaining, and routing, you are quite literally building the robust, production-ready AI of tomorrow. So my final provocative question for you is, which design pattern will you implement first to bring order to your AI applications? The code is out there, it's time to start building. Thanks for joining me on this explainer, and keep learning.